Hello and welcome to the first lecture of Bipolar Junction Transistor. Bipolar Junction Transistor or BJT is a solid state three-terminal semiconductor device. It was invented by John Warden, Walter Bertan under the leadership of William Shockley. William Shockley is also known as the inventor of PN junction diode. For this pioneer work, they all got the Nobel Prize for Physics in 1952. The first bipolar junction transistor was fabricated and invented in AT&T Bell Laboratory, USA. All the electronic devices are generally made up of semiconducting material such as germanium and silicon. Here, silicon is preferred material to design an electronic component because its better stability and abundance availability. It is used for the amplification and switching purposes. The main application of the amplifier is finds in analog integrated circuit. However, switching is the important process for the digital system. The first commercial application of bipolar junction transistor was held in telephone switching circuit in 1952. For the integrated circuit, bipolar junction transistors are integrated and interconnected on a common substrate. Here the word bipolar is used that describes both type of charge carriers, that is majority charge carriers and minority charge carriers are involved in the operation of bipolar junction transistor. That is why the word bipolar is used. This is the first image of point contact bipolar junction transistor which was fabricated in AT&T Bell Laboratory in 1947. This is the image of modern bipolar junction transistor which you can find in any electronic laboratory over the experimental bench. This is the external appearance of digital integrated circuit, also known as the IC chip. Here the key element of IC is the transistor which is act as a switch. This is the image of analog electronic equipment in which BJT is act as an amplifier. This is an image of central processing unit which is also known as the heart of computer system. In CPU, a lot of integrated circuits are integrated and interconnected. For this, again, in IC, bipolar junction transistor plays the major role. A bipolar junction transistor has a silicon or germanium crystal. It would either have a layer of p-type semiconducting material, it's sandwiched between n-type of semiconducting material. It will take the shape of NPN transistor. On the other hand, when an n-type material is sandwiched between two p-type material, it will take the shape of PNP transistor. This sandwich of semiconductor is very small and sealed inside the metal to protect from the moistures. From the figure, it is clear that BJT has a three regions, namely emitter, base and collector, and two junctions. The junction from the emitter side is called the emitter junction and the junction between collector side is called the collector junction. The emitter is placed one side of the transistor. This region provides the charge carriers, either electron and hole, to the base and collector. The emitter junction is heavily doped in nature and medium in area. The base region is lightly doped in nature and smaller in area. The physical appearance of collector region is larger in all and the doping concentration is moderate. That means the doping concentration of collector is in between base and emitter. It has two junctions, namely emitter junctions and collector junction. The junction between emitter and base is also called emitter base junction. The junction between collector and base is called collector base junction. From the concept of PN junction diode, we know that in p-type semiconductors, holes are the majority charge carriers, electrons are the minority charge carriers, and negatively charged carrier immobile ions are present in an p-type semiconductor crystal. However, in n-type semiconductor, electrons are the majority charge carrier, holes are the minority charge carriers, and positively charged immobile ions are present within the n-type crystals. When p-n junction is formed, the holes from the p side move towards the n side and the electrons from the n side move towards the p side. In the process of movement, electrons and holes are annihilated and left behind only negatively charged immobile ions on the p side and positively charged immobile ions on the n side. This process is called diffusion. As soon as the diffusion process, this diffusion process is exists for a very short period of time. Around the junction only, from the figure you can see around the junction only negatively charged are present in the p side and positively charged immobile ions are present in the n side. This will create a barrier potential across the junction and restrict the movement of charge carriers, that is electron and hole, from one region to another region. When the emitter, base and collector junctions are open, this condition is called the unbiased condition. It means no external voltage source is applied across the junction. As soon as the junction is formed, the diffusion process of diffusion starts and a barrier height is created or depletion layer is formed that will restrict the movement of charge carrier from a region of high concentration to the lower concentration. Here it is seen that the penetration of depletion layer towards the base side is wide. However, the penetration of depletion layer towards the emitter side is less. This has happened due to the different doping concentration of emitter and base region. In the same way, collector side is moderately doped than base side. So depletion layer penetration towards the base side is more and towards the collector side is less. If you compare the emitter and collector depletion layer penetration, it is seen that emitter side width is less as compared to the collector side because emitter is heavily doped in nature and collector is moderately doped in nature. In real practice, there is no use of unbiased transistors and the barrier height of the junction is about zero point 0.7 volt for silicon transistor and about 3 volt, zero point 0.3 volt for germanium transistor. For the PNP transistor, it is also seen that the penetration of depletion layer towards the emitter side is less and penetration of depletion layer towards the base side is more. From the figure, it is also clear that the penetration of depletion layer towards the collector side is less and towards the base side is more. This happens due to the different doping concentration of by different regions. Thanks for watching the video.